So 11.4 is on multiplying and dividing rational expressions, and we learned how to simplify them yesterday in 11.3. So today we're going to learn how to do something with those now that we can simplify them. So our first example will be we have 5 over 2x cubed times 4x cubed divided by x plus 1. Now, I put parentheses around the polynomial because I want to remind myself I cannot split this up. This is one number together. But anything else, we can simplify. So we could go ahead and multiply, and we could get 5 times 4x cubed. It's a monomial, so I can just multiply it as 20x cubed over 2x cubed times, again, x plus 1. We have to leave it like that. I'm going to leave it instead of distributing because I want to be able to see what the factors are. So I want to leave it in factored form. Now, x plus 1, again, we can't break it up unless we find another one that's identical to it. But I can cancel out my x cubed because x cubed divided by x cubed is just 1. And then 20 divided by 2 is 10. Technically, these cancel to a 1. They don't cancel, they reduce. And then we're left with 10 over x plus 1. And we do need to state that x couldn't be negative 1, and back to the beginning, it also couldn't be 0. Now, there is a shorter method. So instead of multiplying and then reducing, we could have reduced from the beginning and said, well, x cubed divided by x cubed is 1, and 4 divided by 2 is 2, and this would become, again, another 1. And then we can multiply, and we would say 5 times 2 is 10, and 1 times x plus 1 is x plus 1. So we could simplify from the beginning, or we could simplify after multiplying. For the next one, we have h over h plus 2 times h squared plus 5h plus 6 all over h squared. And again, I want to go through and say, where are my polynomials that I cannot break up? Okay, so this is one number. I have to find something identical to it before I can simplify it. I might be able to factor it to break it down. And this is another polynomial, so I'm going to put parentheses around that as well. So we could simplify early on and say that h divided by h squared is going to give me a 1 up top, and that squared is just going to become an h. Let's see if we can factor this. So we have h times h is h squared. What numbers multiply to 6 and add to 5? Well, that's 2 and 3. So I'm going to scribble this out, okay? And then, hey, check that out. H plus 2 can cancel with h plus 2 because they are identical. So I end up with 1 times h plus 3 is h plus 3, and 1 times h is h. H could not be 0, or back to the beginning, it could not be negative 2. All right, so now we're going to divide the fractions. And a quick reminder, when we are dividing by fractions, we multiply by the reciprocal instead. And again, we're multiplying by the reciprocal of the fraction that was dividing. So what that looks like is if we have 8 over w minus 4 divided by w over w minus 4, then the fraction that we're going to be flipping is the second one, so that it'll become 8 over w minus 4 stays, and this is now w minus 4 over w. Okay, these two are polynomials. I cannot split them up unless they are the exact same, which we happen to have, so they cancel. And we're left with 8 over w. Now, when we look at our excluded values, we need to look at the entire problem. Say that w can't be 0 or 4, And that 4 is repeated early on, so we don't have to list it again. All right, the last problem we're going to do is p squared minus p minus 6 all over p plus 1 divided by p squared minus 4, and there's parentheses around this. Okay, so this isn't a fraction, but we are going to make it a fraction so that we can multiply by its reciprocal. So we just put it over 1, and we're going to flip that one. So now it's p squared minus p minus 6 over p plus 1 times 1 over p squared minus 4. And again, polynomials get parentheses because I cannot split them up. But let's see if any of them can factor. So if we change this one to be numbers that add to -1 but multiply to -6 would be -3 and +2. Okay. And then this one can factor. Numbers that multiply to -4 but add to 0, because there's no middle term, would be p plus 2 and p minus 2. So that disappears. Okay. All right. So let's see what can cancel. We have p plus 2 in both areas, so those can go away. I need to remember that p cannot be -2, though. That's one of my excluded values. We can go ahead and list that it can't be +2 or -1. Okay. All right, so then let's see what we have left when we multiply. So we have p minus 3 times 1 is p minus 3. We have p plus 1 times p minus 2. None of those can cancel because they're all polynomials, which means they have to be identical. And we're just going to include our excluded values over here. And we will box our answer. And that's it. That's it for lesson 11.4. Let me know if you have any questions when you're done.